Okay, today I'm going to be talking about logarithm rules. Okay. I'll be referring to a document as I go. Now what I'm going to do is I'm going to be introducing the rules using illustrations with only one rule at a time. So I'll start with illustrations for just rule number 1. Okay, and these are just illustrations of the rule in action. Okay, and then after I do that, I will show you this in action, and I'll show you that in action, and then I will do formal examples of types of problems that you may encounter. Okay, so starting with illustration number 1, if I had log base 7 of 5 plus log base 7 of k, I could combine that under the sum product relationship because these have the same base 7. I could combine these into log base 7 of 5k. Okay? A similar example, a similar illustration might be this one, where I have, okay, log base 6 of 2e, 2 times e, is equivalent to log base 6 of the 2 plus log base 6 of the e. Okay? I split the logarithm product into the sum of 2 logarithms. Okay? If I had log base 5 of 3x plus log, oops, let me make that bigger. Log base 5 of 3x plus log base 5 of x minus 7. I can combine that into log base 5 of 3x times x minus 7. Okay, using the sum product relationship. Okay, and that would simplify as log base 5 of 3x squared minus 21x. Okay? If I had log base, let me move that up. If I had log base 8 of x squared minus 2x minus 15, well, that's a factorable trinomial. So I'll go ahead and factor it as log base 8 of log base 8 of, and then I will factor this as x minus 5, x plus 3. And then I could split that up into 2 logarithms, log base 8 of x minus 5 plus log base 8 of x plus 3. Okay? And finally, log base 17 of 6xy, well, that's the product of 3 values. I could split that up into a sum of 3 logarithms. Log base 17 of 6 plus log base 17 of x plus log base 17 of y. Okay, for number 2, so I'll be focusing exclusively on this rule. Okay? So let's say I had log base t of 12 minus log base t of 14. I could combine that into, what did I have? Sorry, I switched these. Log base 12 of t minus log base 12 of 14. I can combine this into, because of the same base, under this rule I can combine that into log base 12 of t over 14. Subtraction, fraction, connection. Okay, I could also split a fraction up as well. Okay, and log base 15 of the fraction a over 10, I could split that up into log base 15 of the numerator a minus log base 15 of the denominator 10. Okay? Similarly, log base 6 of x minus 2 minus log base 6 of z plus 9, those two can be combined into, since they're the same base, that would be log base 6 of a fraction with x minus 2 going on top of z plus 9. X minus 2 over z plus 9. Okay? As a fraction. All right. So you can see the connection between addition and multiplication, and subtraction and division. Okay? All right. I will try to fit rule number 3 down here. I originally wasn't going to attempt to do so, but I think I will anyway. Okay? Log base 4 of x to the 6th. I wrote differently than I have it on the paper. Log base 4 of x to the 6th, I can take the 6 to the front, and that would leave me log base 4 of x. Okay, the exponent went to the front. Okay, and if I have 7 log base 5 of t, I can take the 7 and move it into the exponent. That would give me log base 5 of t to the 7th power. Okay, taking the t into the exponent. All right, something else. Log base 7 of the square root of n. Well, folks, the square root of n is n to the 1/2 power. Log base 7 of n to the 1/2 power. Okay? And using rule number 3, I can take that 1/2 to the front, giving me 1/2 log base 7 of just n. All right? And then finally, 5, natural log of 2. Well, folks, that's log base e. Okay? I could move the 5 into the exponent, so that gives me the natural log of 2 to the 5th. And 2 to the 5th, folks, is 32. All right. So these are the 3 rules in isolation. I will erase the board. I will erase the board and put examples up on the board. Okay, with example 1, I'm going to take this logarithm, I'm going to split, and I'm going to separate or expand it. I'm going to make as many logarithms as possible, and I don't want any exponents and radicals when I'm done. Okay, so the first thing I'm going to do is I'm going to notice this is the logarithm of a fraction, so I will split it. Okay, so that would give me log base 7 of 11x squared cube root of z minus logarithm of the denominator, like so. Okay, so my first order of business was to use this relationship to split that up into the logarithm of the numerator minus the logarithm of the denominator. Now, what I'm going to do here is I'm going to go ahead and write this as log base 7 of 11x squared z to the 1/3 power, because the cube root of z is the 1/3 power, minus log base 7 of 5w. And then what I'm going to do is I'm going to split these and split those using the sum product relationship. Okay? So that's going to be log base 7 of 11 plus log base 7 of x squared plus log base 7 of z to the 1/3. Now, because this entire value is being subtracted, the entire splitting of this needs to be in parentheses. So minus, and then I'm going to split that up into log base 7 of 5 plus log base 7 of the w. Okay, I'll do that again. We're going to do this entire step again. Okay, so using this relationship, the sum product relationship, I'm going to combine this. I'm going to expand this into log base 7 of 11 plus log base 7 of x squared plus log base 7 of z to the 1/3. Okay? Now this entire logarithm is being subtracted. So when I split it, it needs to be treated as a subtraction of whatever it's split into. So I'll use a bracket, and that's going to be, under the sum product relationship, that's going to be log base 7 of the 5 plus log base 7 of the w. Okay? And that's going to be a distributive property situation when I get there. So this will be log base 7 of 11. I'm going to use this relationship to eliminate these exponents. So 2 will go to the front. So 2 log base 7 of x plus, I'll move the 1/3 to the front, log base 7 of z, minus log base 7 of 5 minus, because I distributed through both of them, log base 7 of w. There are no exponents, there are no radicals, and this is expanded to as many logarithms as possible. Okay? All right, I'm going to pause here and set the next example. All right, I'm ready to resume. Using this rule, we want to combine these into a single logarithm, and what we need to be able to do is we need to have nothing but logarithms. So these need to go out, these need to be put into the logarithms. I'll use that relationship to get 8 into the exponent and 2/5 into the exponent. Okay? So that will be log base 4 of a to the 8th plus log base 4 of d to 2/5. And since these are going to have to be combined into a single logarithm, I would prefer to do that using this method, so I will factor out the negative. Log base 4 of 3x plus, factor out the minus, so plus log base 4 of 10y. Okay, I factor out the negative, that made that positive and that positive. Okay, so I'll use a sum product relationship here. This will be log base 4 of a to the 8th d to 2/5, using this relationship right here. Minus log base 4 of 3x times 10y. 3x times 10y under the sum product relationship. Okay? Which should give me log base 4 of, I propose to change that to the 5th root of d squared. Okay? Minus log base 4 of 30xy. And then I'm going to use the subtraction fraction connection to combine these into the logarithm base 4 of this over that. All right. Example 3. Two natural log of 4 minus, so the same rules, same procedure, same rules. 2 natural log of 4 minus natural log of 11 times k plus natural log of 15x minus the natural log of 6. Okay, so for this to work cleanly, I need to factor out a negative out of the last 2 terms. And for that to work, or out of these terms. And for that to work, I want all of my negative terms to be at the end, as they were in example 1. So I want to get this and this at the end, like I had it there. Okay? So this will be 2 natural log of 4 plus natural log of 15x. And because this is the same as adding a negative, I'm going to put this at the end. Minus natural log of 11k. I'll go ahead and put it in parentheses. I don't have to, but I will. Okay? Minus natural log of 6. All right. So, what I will now do is I will use this relationship to get the 2 into the exponent. So this will be the natural log of 4 squared plus natural log of 15x. I don't know why I took it out of parentheses. I shouldn't have. Okay? And then I'll factor a negative out of these 2 terms. So that would be the natural log of 11k plus the natural log of 6. Okay, using the same method I used there. Okay, so this will be the natural log of 16, because 4 squared is 16, plus the natural log of 15x minus the natural log, using the sum product relationship, of the natural log of 11k times 6. So this will be the natural log of 16 times 15x, using the sum product relationship, minus the natural log of 66k. Which would give me the natural log of 240x minus the natural log of 66k. And using the subtraction fraction relationship, I will combine that in the natural log of 240x over 66k. And I will notice that this is reducible. 240 and 66 are both divisible by 6. So I'll simplify the fraction. Natural log of 40x over 11k. Okay? 240 divided by 6 is 40. 66 divided by 6 was 11. I am done. Okay? I'll pause here and set up a final example. All right, and to emphasize the fact that for these rules to work, they have to be the same base, I created an example where we had multiple bases. Base 5, base 8, base 5, base 8. So to do this, since we have 2 different bases, 5 and 8, the fewest logarithms we could get is 2 logarithms, because there's 2 bases. Okay, so I'm going to move the base 5s to the front. 6 log base 5 of x plus 3 log base 5 of 7. So the base 5s are going to move to the front. I'll put the base 8s together as well. Plus 4 log base 8 of x plus log base 8 of x to the 11th. Okay, so the base 5s are together, the base 8s are together. So basically I'm going to be doing two of the same types of problems we were doing with examples 2 and 3. Okay? So I'm going to get rid of the exponent using this relationship. So this is going to be log base 5 of x to the 6th. Okay? Plus log base 5 of 7 cubed. Okay? Plus log base 8 of x to the 4th. And then I already have this is already a lone logarithm without anything being multiplied. All right. Next, I'll calculate this, and I'll be using the sum product relationships as to combine these. So this is going to be log base 5 of x to the 6 plus log base 5 of 343. Okay? I'm ready to combine these already. Log base 8 of x to the 4th times x to the 11th using the sum product relationship. Okay? So, these two will combine under the sum product relationship as log base 5 of 343 times x to the 6th. Okay? And these two will combine into log base 8, x to the 4th times x to the 11th, you have the exponents, x to the 15th. Ladies and gentlemen, this is as far as we can go because these are different bases. All right, I'm done.